Hello everyone. I hope everybody done their assignments regarding lithium aluminum hydride. So here I am going to introduce one more reagent which is also reducing time. So lithium trialkali aluminum hydride. So here the modified thing is here alkyl group is going to add it. So trialkyl group is going to add it with the lithium aluminum hydride. Okay. So just a minute. Now, how to make that 4 out of 4 hydrogens replaceable, replacing of 3 hydrogens. Okay. So, if you can see in the preparation, here lithium aluminum hydride is treated with 3 moles of alcohols. If you want to make ethoxy lithium aluminum hydride, you need to treat with 3 moles of ethyl alcohol. If you want to make tri-butaxy, tertiary butaxy lithium aluminum hydride, you need to treat with 3 moles of tertiary butyl alcohol. 4th mole is not possible because of the steric index. Okay, so only up to 3 alkyl groups are going to replace with the hydrogens. Okay, so this is the preparation time. So first reagent, tri-butaxy lithium aluminum hydride. So as the alkyl groups are going to add with the lithium aluminum hydride, their reactivity of actual lithium aluminum hydride, where the 4 hydrogens are there, it is more prominent towards the reduction. So more reactivity of the reduction. So lithium aluminum hydride is highly reducing agent. Okay, and as the alkyl groups are going to add up, so reactivity is decreased. Okay, what reactivity is decreased? Reducing reactivity decrease. So this is a strong reducing agent. This is little weaker. Okay, as the bulky groups increases, it will be going to weak. Okay, so this is the weaker one. So as the strength of the reducing nature is going to decrease, the same way the functionality of the reduction is also going to reduce. So lithium aluminum hydride is able to reduce the carbonyl compounds, acids, esters, amides, nitrites, azides, everything into the reduced form. Okay, so if it is nitrogen functionality, they are going to convert into the amine. If it is oxygen functionality, they are going to convert into the alcohol. So now with lesser reactive partner, like lesser reactive reagents like lithium tri-tertiary butaxy alkane hydride. So you can comfortably convert acid halides, okay, acid halides into the alcohol aldehydes. Okay, acid halides into the aldehydes. So these type of specific reagents are very much important, so that you can convert the acid halide into the aldehyde unless into the alcohol. Okay. So if you use lithium aluminum hydride, you are going to get direct alcohol because of the strong reducing nature of the lithium aluminum hydride. So at the same time, if you use tri-butaxy lithium aluminum hydride, you can convert into the aldehyde, and their reaction will stop because of the less reducing nature of the alkoxy aluminum hydrides. Okay. So one more example of the substituted lithium aluminum hydrides. So tri-ethoxy lithium aluminum hydride. So in this also it is less reducing nature. So cyanides, that is nitrate. Okay. Sorry, nitrates. So earlier in lithium aluminum hydride, nitrites are converted into the amides. Okay, amides, because of the complete reducing nature. But here, these nitrites can convert it into the aldehydes. Tri-butaxy will convert acid halide into the aldehydes, and tri-ethoxy lithium aluminum hydride will convert with nitrites into the aldehydes. reagents. Okay? These are specific reagents that can use especially for these type of transformations. Okay, so these are very important. Okay, now the next modified reagent is sodium bis 2-methoxyethoxy aluminum hydride. Okay, sodium bis 2-methoxyethoxy aluminum hydride. So aluminum has two hydrides. Okay, and two methoxy. So this is what in short term SMEH, sodium bismethoxyethoxy aluminum hydride, SMEH, or simply you can say red aluminum. Okay, so this is simply, this reagent is called red aluminum. Okay, so it is highly important reagent because it can apply for modified reducing nature. Okay, in various functional groups. So if you can see the functional groups transformation. So if it is imine, it can convert into the amines. Okay, so if it is ester, it is converted into the alcohols. If it is anhydride also, it will convert it into the alcohols. If it is acid halide or acid, it will convert it into the alcohol, that is primary alcohol. If it is amides, they are converted into the amines. If it is carbonates, they are converted into the alcohols. Okay. If it is aldehyde, it is primary. If it is ketone, it is secondary. Aldehyde, ketone. Okay. If it is nitro, it will convert into the amide. Okay. So nitro and amides are also converted into the amide. Okay. So this is what the basic nature. Okay, reducing nature of the radar. Okay, much similar to the lithium aluminum hydride. So its strength is much similar to the lithium aluminum hydride. So major changes, okay, are differences with the lithium aluminum hydride and red aluminum is the lithium aluminum hydride can convert all the carbonates into the alcohols, whereas red aluminum can convert into the aliphatic carbonyl compounds into the alcohol, whereas aromatic carbonyl compounds into the hydrocarbons. For example, if I take acetone, it will be converted into the ethanol, both with red aluminum as well as lithium aluminum hydride. Okay. But if I take benzoyl, okay, benzoyl and treated with lithium aluminum hydride, it's going to give benzyl alcohol. Okay, as expected. If it's same treated with red aluminum, that will convert into the toluene. Okay, this is one of the basic difference. So this is the highly important area where question may arise. Okay, the same thing. This is highly useful in the conversion of conjugated carbonyl compound into the only carbonyl compound where unsaturation is going to reduce. For example, if I use conjugated carbonyl compound like this. Okay. If it was a lithium aluminum hydride, it will convert both unsaturation, okay, as well as it will reduce unsaturation as well as the carbonyl compound. So finally it's going to give the alcohol here. Okay. So to completely saturated alcohol. At the same time, if I use red aluminum, it's going to give only carbonyl compound without unsaturation. So it's going to make a saturation of the conjugated carbonyl compound. So this is about modified lithium aluminum reagents. Okay, modified lithium aluminum hydrides. Okay, So now the assignments. So assignment is to write the products succinic acid treatment with lithium aluminum hydride as well as the radar. Number 2, benzoic acid. Same, lithium aluminum hydride and red aluminum. Okay. Number 3, benzoate. Lithium aluminum hydride and lithium aluminum tertiary butyl oxy tertiary butyl oxy hydrate. Okay. Next, number 4, benzoyl. With the red aluminum and with the lithium aluminum tertiary butyl oxy hydride. Next, benzoate. Treatment with the red aluminum. Next is this one, cinnamon. Next, benzonitrile, lithium aluminum hydride as well as the triethyloxyl aluminum hydride. So these are the assignments that you need to work out. So after this, you need to send the assignments immediately on the same day through the WhatsApp. Okay, I expect you all will send the assignments. Okay, thank you.